Okay, this lesson is going to be 4.1, so listen to the homework and notes and then complete the homework on Delta Math. So today we're going to talk about congruency, which we're actually going to connect to what we did back in topic 3 with transformations. So I'm actually going to start off with what we did just last unit. So understanding congruency, it says, suppose there's a rigid motion that maps one figure to another. Why does that show that two figures are congruent? Well, let's just think about what the definition of a rigid motion is. Okay, the definition is a rigid motion, okay, is where the size and shape are preserved. Well, if the size and both the shape and size are preserved, then what that means is that the shape is the same, or in other words, the shapes are congruent. So in other words, when we talk about a rigid motion, we're also talking about congruent shapes. So let's just give an example of this. So it says a 90-degree rotation about the origin maps PQR to LMN. Are the triangles congruent? It would be yes. Okay, because rotation is a rigid motion, and from what I discussed from before, that a rigid motion, the size and shape stays the same, so therefore, I do 3 dots for therefore, the triangles are congruent. Okay, they're the same. Okay, so yeah, we're just going to kind of play on this idea of congruency and what does it mean to be congruent. So it says in this next part, it kind of summarizes what I just talked about. So it says figures that have the same size and shape are said to be congruent. Okay. Two figures are congruent. Okay. If there's a rigid motion that maps one figure onto another, you can also have like a composite rigid motion. So like a translation, a rotation, a reflection, a rotation, a translation, and a reflection. You can have more than one. We also call a rigid motion, this is a synonym, we call it a congruency, okay, transformation, okay, and also one other term that is known as, okay, is we refer to it as isometry. Okay, so all those 3 words, rigid motions, congruency, transformation, and isometry mean the same thing. Let me just do this really quick, guys. Cool. Okay, so we're just going to play around this. So this is the symbol that means congruent, to show two figures are congruent. So in this example, it says since R, you're reflecting over line M, ABC, it maps onto DEF. So therefore, we can conclude that ABC and DEF are congruent to each other. Okay. So looking at this one, it says verify congruency. So it says use rigid motion, so it's going to be 2 or more, to verify that XYZ is congruent to ABC. Is there a rigid motion that maps ABC onto ABC? Okay, so remember, we're going to start with, this is going to be the pre-image here. Okay, and then this is the image here. So we're going from XYZ to ABC, which the order does matter. Okay, so I'm going to pick 2 points. The nice part of this is the letters do align. So in other words, what I can do is I can pick like point X, okay, which is at this point right here, -6, 2, okay, and I'm going to see how I can map it onto eventually how to get to A, which is going to be at 5, 2, okay. So we just need to kind of fill in what we need to do. So the first thing I noticed is that this triangle is again essentially getting flipped on its back. So I could do this. I could do the first part. You could do a rotation. And if it's getting completely flipped around, that means it's rotating 180 degrees clockwise. So I'll write it like this. So lowercase r, 180 degrees clockwise, and then about the origin. Okay, what you have to do then is you have to look at where you're landing on that and then go from there. So if I rotate this point, the new point for that rule is going to become like essentially just the opposite. Okay, so it's going to be, this is the reflection, so it's going to become negative x comma negative y. I'm sorry, going to be the rotation. Okay, so if I flip x, instead of negative 6 comma 2, it would become positive 6 comma negative 2, and so my point would be right down here. Okay, but then I need to get to point A, so what I can do is I can translate. Okay, I can move this here, and then I can move it up 1, 2, 3, 4. So my next step would be translate. Let me spell that right. Okay, and we would write it like this: capital T, it would be left 1, and then up, what did I say, 1, 2, 3, 4. Okay, and then that would get it to point A. So these are the two types. Okay, so in other words, yes, to answer the question, yes. Okay, and therefore triangle XYZ is congruent to triangle ABC. Okay. Okay. So once we have congruency, this is what's known as congruency statements. Okay. What we can do is we can match all the angles and line segments together. So I'll show you how to do angles first. Okay. So for angles, there's 3 pairs because there's 3 angles. Okay. You're going to match like the first layer to first layer, second layer to second layer, and third layer to third layer. So here's what it'll look like. Like angle X would be congruent to angle A. Okay. Then second layers would be angle Y is congruent to angle B. And then finally the last one would be angle Z is congruent to angle C. Okay? And that's because it's a rig of motion. The angles and the segments are preserved. Okay? So then segments, you need 2 letters. Okay, so I'll just do the patterns. Okay, so here's what I would do, is I would do the first 2 letters of the first one, so X, Y, and then is congruent to the first 2 letters of the second part, AB. Okay. Then I can do second to last letter, so it could be YZ is congruent to BC. Okay. And then finally the last one I could do the final part, so it could be XZ, first to last, is congruent to AC. Okay, so that's what I can come up with, that congruency statement up there. Okay. Yeah. Okay. So here's what I want you guys to do. I am going to post this answer key, but for right now, I want you to pause and try number this one. So what's one composite that maps JHJ and LMM, and then what it goes also the other way. I'll give you, pause this video for now, and I'll go over it in the video. Yeah. Okay. So make sure you pause this and did it before you just move on. Okay, so here's what I'm looking at. It says, given GHJ is congruent to KLM, what is one composite of rig of motions that maps? It order matters. You got to go from left to right. Okay, so here's what I would do, is I would pick 2 points like that we know align. So like I could pick point G here, which is the point, it would be, what is it? -7, -2. Okay. And then pick the point here, M, which is at 2 comma -7. Okay. So here's what I'm kind of looking at, is I'm thinking like, okay, like essentially how do I get from there to there? Well, it almost looks like it's like a flip, like where we flip like this shape here onto that shape. So in other words, a flip is known as reflection. So we need to find the line of reflection. So we actually did that. Okay. Remember how we did that? We would find, like, it's the equation of a line. So you need your slope and then basically find the perpendicular slope through there. Okay, so here's what I would start off with first. I need to find the midpoint between these 2 lines. So what I'm going to do is I'm going to do the midpoint from G to M. Okay, And so that's going to be negative 7 plus 2 divided by 2, comma, negative 2 plus a negative 7 divided by 2. Okay, and so what I would get is it would be a decimal, it would be negative 2.5, comma, it would be negative 4.5. Okay, and what I would do is plot that. Okay, so applying that just roughly, it would be negative 2.5, comma, 4.5. It's like right here. Okay, that's your midpoint. And then what I would do is connect those two through the midpoint. Okay. All right, so then remembering the line of reflection is perpendicular. So what I need to do is I need to find now the slope of GM. Okay, so it would be y2 minus y1, so I would do negative 7 minus a negative 2 divided by 2 minus a negative 7. Okay, and so I would get, it would be negative 5 on top because it's double negative, and then on the bottom it would be 9. Okay, so then that's the slope. So when you need to figure out the slope, that's perpendicular. Okay, so perpendicular, so it means I switch it and then negate it. So it would be, what is it? 9 over 5. Okay. Okay. So here's how I'm going to do this. Okay. That's going to be where the line of reflection is. I would not go based off the graph, okay? And it's because it's harder to pick out. So what I would do is that you have a point, you have a slope, and I would just plug into this is x, this is y. So I would do y equals mx plus b. So it'd be negative 4.5 equals 9/5 times x, which is negative 2.5, and then plus b. Okay, so I'm solving for b in other words. Okay. And so when I actually solve for b, that would actually just be 0. Okay, and so what I would finally get for my final answer is it's a reflection, okay, over the line y equals your slope, 9/5 x, and then plus b. Okay, so in other words, you could just reduce it. It would just be the line y equals 9/5 x. Okay. So then it says in part B, what would be another composition of rigid motions? So another composition, I'm not going to do this all by out, but you could do actually a rotation, okay, and then a translation. Okay, you need both of those because it can't just be one. Okay. Okay. Cool. Okay. So then this one, it says given A, B, C, E, F, G, and H or J, K, L, which triangles are congruent? So here's what I need to do. When you're talking about congruent triangles, you're talking about the measurements being equal, or yeah, okay? Measurements being equal. Okay. So in other words, their side lengths have to be the same. So how would I figure out each one of their side lengths? Well, that's by distance. Okay. So I'm actually going to use distance formula. Okay, so it connects. Okay. All right, so here's how I'm going to do this. I'm going to pick just the sides, and pick one side that aligns. So I could do side AB, the distance of that, EF, okay, and then JK. If you pick one aligning part and figure out which two of those are equal, then that gives you all the answers. Okay. So here's what I'm going to do. Find the distance from A to B. Okay. Remember Pythagorean theorem? Here's what I do. A, B. Okay, so I'm creating a right triangle. So I would count up 1, 2, 3, 4, and then over 1. So here's what I use. I would do the square root of 4 squared plus 1 squared. Okay. So that would equal square root of 17 because it's 16 plus 1. Okay. I'm just going to repeat that for all the other ones. So distance from E to F. Okay. I'm using Pythagorean theorem. So E to F, that's actually just a straight line. So when you count, it's just 1, 2, 3, 4. It would just be 4 there, just by counting. Okay. And then I still have to use the same trick from, what is it? J to K. Okay. So that would be from here to there. So in other words, it would be 1, 2, 3, 4 steps up. So I'm creating a right triangle. Okay. And then 1 step over. So now it'd be, again, 4 squared plus 1 squared. And so that would be the square root of 17. Okay, so now looking at that, I know that this and that are equal. So in other words, I've just confirmed that AB, this is kind of like a mini proof, is congruent to JK. So in other words, what I can say is that triangle ABC is congruent to JKL. Okay. Okay. All right, so I want you guys to try this one. So I'm gonna move over this one. I will post an answer key later today. Okay. And then finally, this last part. Okay, so it says determine congruency. So just which pair of objects are congruent. If a pair of objects are congruent, describe a composition of rigid motions. Okay, so like this one, if I look at the two shapes, I'm just seeing that they look the same and they're the same size. So in other words, these two shapes will be congruent. And how so? Well, it looks like it's a flip, okay? So a flip, in other words, would be a reflection, which is a rigid motion. Okay. This one, what I'm noticing is that this length up here is bigger than this length up here. So they are not congruent because they're not equal. So this would be just no. And then finally, the last one would be right here. Okay. So I can see that the boxes are the same. So that would be congruent. Okay. But now what I'm noticing is that it's almost like a turn. Okay. So in other words, that would be a rotation. Okay. Yeah. And that would be it. Okay. So that's lesson 4.1. So your homework tonight is going to be this office practice. Okay. Posted. Okay. And I'll be back tomorrow.